Hi everyone and welcome to our poster. I'm Samriddhi and I work as an applied scientist at Amazon. I'll be giving you an overview of our paper Semantic Complexity in End-to-End Spoken Language Understanding. This is a joint effort with my colleagues at Amazon. In this work, we study the limits on the performance of a class of SLU models called end-to-end models. These models are trained to predict the semantics of a spoken utterance directly from speech using a single model instead of using two component models in a sequence, as is generally done in a traditional SLU approach. End-to-end models are trained on a single optimization objective, making them robust to component-specific errors. Moreover, they are resource and latency efficient. Instead of having multiple models to get the final interpretation, we now have a single model, often with fewer total number of parameters that can predict the final output. This class of models has seen an explosion of interest in research and industry recently. Multiple end-to-end architectures have been proposed that report more than 96% accuracy on average. However, we noticed that these results were often benchmarked on datasets with limited complexity. These datasets have moderate number of unique utterances, limited number of semantic classes, and a limited vocabulary set. The question about how well these architectures generalize to broader use cases is often unexplored. This broad applicability is especially important for a commercial voice assistant system like Alexa, where we need to support a broad range of actions, strive to be more conversational, and give the customer the flexibility of phrasing a command in a natural way, increasing the vocabulary set by a lot. We studied this problem by proposing several empirical measures to quantify the semantic complexity of an SLU use case. Specifically, we look to answer two main research questions. First, can we quantify the semantic complexity of an SLU dataset? And second, does the performance of an end-to-end model vary depending on the complexity of a dataset? There are two classes of measures that we propose: the lexical measures that utilize the linguistic features of a text, and the geometric measures that are computed using the sentence embeddings of an utterance text. We measure the complexity of three public datasets and show that the near perfect accuracy that is reported for them is associated with their low complexity values. Second, we train multiple end-to-end architectures on datasets of varying complexities and show that the performance increases as the complexity values decrease across all the architectures. And finally, we ask the community to use these measures to contextualize the performance of their models to reveal the scope of their applicability. Thank you and see you in the summit.